Welcome back to the UGC lecture series on laser physics. We shall now continue about the description of continuous wave argon ion laser. When I say it is a continuous wave laser, it should have 4 energy levels. I have shown you the energy levels of argon ion laser media. It starts with the E0, E1 and E3. Now, for all our laser action, what happens is, if you go back to the discharge, the current discharge is so high, so intense that you get a current of about 10 ampere, 15 ampere, like that is the level of current that you get. Because when you say so much current, so many number of electrons are running back and forth, they will hit the argon atom, produce argon ion, and that argon ion is the laser medium. Now, it is not the argon atom, it is argon ion, which is a two-step process. That is, you excite argon atom from E0 to E1, that is the excited state of argon atom. Then kick it from E1 to E3, this is the energy level of argon ion. The point is, you see the blue line on the top, you can see there is a bunch of energy levels in which E1 argon is taken up, argon ion is taken up. They are called the pump levels. From there, those ions come down to the lower energy level, which is the E2, which is another energy level, and below that there is another level. So, the ground level is different from the lower energy level, pump level is different from the upper laser level. Because of these advantages of 4 energy levels, let me repeat: ground level, pump level, upper laser level, lower laser level, all put together forms the 4 cycle essential requirement for a continuous wave laser, and this satisfies very well for argon ion. Because of this one, you will get laser action many wavelengths. In fact, from that you can have many wavelengths. The most prominent are 5145, 514.5 nanometer, another one is 488 nanometer. These are the two prominent wavelengths. 488 will be beautiful blue green, and 514.5 will be a greenish color. When they come out, it will be a sight to see. It is a beautiful color will be there. It will be scintillating, which I have mentioned so many times. The speckle from them, if we allow the laser beam hit the wall, the whole room will be dazzling with blue and green light. Such a laser we can get a laser of the order of 1.5 watt, continuous 1.5 watt at 488, and 514 also more or less same energy. There are some lines still in the violet also, some light beyond 48. If you put all these lines together, you can get 5 watt power from argon ion. Now, how do we get one line in preference to another? We can easily employ a grating somewhere. We can choose some kind of frequency selecting element somewhere between the two mirrors. You can choose a particular wavelength, allow that particular wavelength alone to go back and produce laser action at blue or green or at violet. There are so many possibilities. I am just giving the schematic. With this, the argon ion laser is a very versatile, very powerful and very useful laser. the most interesting point is this particular argon ion laser is the most wanted in ophthalmology centers, because this is the laser which will be very useful for diabetic retinopathy. What is the diabetic retinopathy? It is important to tell you at this point. For some people who have been diabetic for a very long time, their blood vessels are swollen, become bigger, and the blood vessels become weaker also. When they become weaker and bigger, they easily get punctured. So, blood will come out, ooze out. When this happens in some part of the body, it is a minor problem. It is a problem, but minor problem. On the other hand, when it happens in the retina, the blood vessels spread out blood, and when this happens, they could not see things properly. Under this condition, they go to the doctor. About 50 years ago, there was no remedy. There was no remedy at all. I am not joking, there was no remedy at all. So, doctors will say, just get along with this one. Now, go to ophthalmologists, they make use of this argon ion laser. These 488 514 are wavelength which are transparent to eye. 480 is a green. Green is the color of the leaf, and we all love greens. Animals love greens because green leaves give us the food. So, our nature has given high sensitivity, it allows 488 go very well inside. So, if we use a 488 nanometer laser, the eye will happily allow, it will not absorb, that is the biggest advantage. It can be focused on the blood vessels of the retina, wherever there is a puncture. Then you can seal it like a welding, you can seal, heat it and weld the tissue nearby. If we heat it and weld the tissue nearby, that tissue, that blood vessel may not be really useful or partially useful, but the blood oozing has been stopped. Since the blood oozing has been stopped, with the other blood vessels, optical nerves still will be function. People can see clear cut images even after this argon ion laser therapy, or argon ion laser surgery. It is not a therapy, argon ion laser surgery of the retina. They can have a very normal healthy vision, normal healthy life. This was the most respected medical applications of laser throughout the world. Okay. This particular laser has another advantage also. This can be easily launched in the optical fiber, can be easily put in the optical fiber. Wherever there is some problem in the mouth or in the stomach or any part of the body, they can do surgery using this argon laser also. So, this is one of the important surgical laser also, but more importantly it is the best for ophthalmology. Now, we will pass on to the next important laser, which is a nitrogen laser. All the time we have been seeing a solid state laser, ruby laser typical example, then dissolution laser which is a liquid laser as an example. Argon ion laser is a very good medical laser which produces laser at 488 or 5114 nanometer. This is all in the visible region. Now, we are going to pass on to another very fascinating laser, nitrogen laser. This is a molecular laser. Here nitrogen molecule is compelled to produce laser action. The energy level of a nitrogen molecule is given here. Let me explain the discharge channel. Yes, this is the totally new type of laser. In this case, we take nitrogen gas in a long tube for about 1 meter length. It may be a glass or even a perspex. keep the nitrogen gas continuously flowing from the nitrogen cylinder, which you can buy anywhere else, which is commonly available. From the nitrogen gas cylinder, you connect to the laser channel. Then other side you have a vacuum pump. Then what would happen is, if you use the vacuum pump, it will remove all the air or most of the air. We do not have to remove completely, we remove most of the air and then keep allowing the nitrogen gas open it. Then nitrogen gas will be flowing through this one. The pressure inside can be about 1 or 2 torr, that is all. We need that kind of pressure, that is all. Then if we produce intense discharge between two long horizontal electrodes, two metal rods, one metal rod, another metal rod running through the entire 1 meter length, if you could produce a faster discharge, then you will have electrical discharge going in this direction, one end to another. Gas is flowing in this direction. When the gas is flowing in this direction, electrical discharge in this direction, nitrogen gas molecule will be excited from one particular energy level to higher upper electronic energy level. That is the active species for nitrogen gas laser. Since the gas is flowing in this direction, discharge is in this direction, we can have two mirrors this direction. Under this condition, spontaneous emission from one particular energy level to another lower energy level will produce sufficient number of light in the ultraviolet region, which can go and get reflected from the mirror, and when it makes even 2 or 3 trances, you will be able to get very good stimulated emission, and then you will get intense laser action in this direction, in this direction. In this case, since the electrode separation is going to be about 1 centimeter or even more, what comes out will be something like a rectangular ultraviolet light. For that, the essential requirement is the energy level are so fast that upper energy level time is only about 40 nanosecond. So, you have to produce intense discharge exciting it very fast. The pump rate should be very high, and that pump rate is very high because of the design that we have chosen. What is the design that has been chosen? See, you see there is a two big sheets of it looks like a big two sheets. It is true, there are two big sheets. These are thin capacitors. Here is one capacitor, another is a thin capacitor, which is very spread out, very thin. Since it is a thin sheets, the inductance for this capacitor is very low. Because of this one, that when you produce a discharge, the current rise will be very fast. It will go from 0 to maximum within about 10 nanosecond. And that particular design is called a Blumlein circuit, which needs more time to explain, which you may not understand at this stage. It will produce a voltage inversion, and then if we apply 10 kilovolts on one side, the other side will reflect the voltage. When it reflects, the voltage will come down to minus 10 kV. Remember, from 0 I apply a voltage of 10 kV which goes up. At one point there is open end which will get reflected to minus 10 kV. All this will be done in a short time of the order of 5 nanosecond. Because of this one, you will have a potential difference between the two electrodes as 20 kilovolt, but this will exist only for a short time of the 5 nanosecond. This is the principle of Blumlein circuit. That is what we want. We want to produce excitation, very high excitation in a very short time. This is something like a lightning. In the lightning, what happens is you have some point at a high voltage, there is another point. Let us say you can imagine that there is a tree which is at 0 potential. The potential difference is very high. So, the discharge takes place from that to the tree. When the potential difference is high and the discharge very fast, the intensity of the shock wave is high, the tree will be split into 2 or 3, it will get burnt everything, all the damages can take place because it is something like a Mike Tyson punch. One punch you will get very good population inversion in the whole discharge, and that produces laser action. That is an ultraviolet laser action. That is the principle of nitrogen laser. This special circuit is a Blumlein circuit. This is something like my baby. This is my research work. This was a very favorite one. Throughout the world, they use the same kind of technique, and everywhere, if you want to have an inexpensive laser that could be home built, people will immediately go for nitrogen laser. What is the use of this nitrogen laser? Since it produces laser at 337.1 nanometer, which is ultraviolet, this particular laser is capable of producing population inversion in a number of dye solutions. Since it is ultraviolet, it can pump practically every dye. So, if you want to have a dye laser from alpha NPO, coumarin, fluorescein, rhodamines, for any type of dye solution, use this nitrogen laser as a pump source. You can mix them all of them can be made to produce laser action by one single nitrogen laser. So, for all dye laser pumping, this is made for each other. Secondly, since this is a nitrogen laser which is ultraviolet, ultraviolet can just fall on suspected lesion of oral cancer. Perhaps you must have heard about it. Oral cancer is very common in India, very common. Perhaps we are the citadel of oral cancer in India because people take tobacco and so many pan barak, so many things. Now, when they have swelling, when they have some kind of lesion, they go to the doctor. The doctor will want to know whether it is due to tumor. It may be a benign tumor or just a growth, or it may be a cancer, we do not know. To correct final way is to take the tissue, go do biopsy. Before that, there is something called leukoplakia, that is a pre-malignant stage. If somebody has a pre-malignant stage leukoplakia, you can bring him, ask him close his eye, open mouth, use this nitrogen laser, allowed to fall on the tissue, not on the person, only on the tissue. If the tissue shows distinct red discoloration, this is due to porphyrin accumulation which is associated with the cancer. So, this is one way of discriminating or detecting early stages of cancer, which was also very successful. So, I mean, this is one of the important applications of laser. What is important at this point of time is this is an ultraviolet pulse laser. Pulse laser means like a ruby laser, it can give pulses 1 pulse per second or 10 pulse per second, not more. Ruby laser will give only 1 pulse per minute. This can give at the best 10 pulses per second, not more, because of its own constraint. Next, let us see another important laser which is called the excimer laser, or exciplex laser. This again has played a very vital role in all medical applications. This is based on a strange kind of species which are called exciplex. What is this exciplex is something very funny. You start with argon and then have chlorine inside. You know, argon is what you call is a totally non-reactive gas. Chlorine is very reactive gas. Under this condition, if you mix them together in a discharge channel, something similar to the same, we can use same in this case, just instead of nitrogen gas, flow argon gas and chlorine gas, that is all. Add helium also to give sufficient some kind of buffering, we call them as a buffer gas. If you mix them all in certain proper proportion, the whole channel will be filled with argon, chlorine and helium, or you can have xenon, any one of these gases. If you produce intense discharge, the discharge will be again of the order of few nanosecond. Then what would happen is, argon will get excited to some high level, chlorine also will get excited to a high level. At the high level, argon ion, chlorine ion both will combine together. Remember, argon is non-reactive, chlorine is very reactive, but under high excitation they come together, make a combination, they get married and become a short lived species called argon chloride, that is what you call exciplex. Then they just settle down from argon ion, chlorine ion, they become argon ion, they come down, settle down to the upper laser level, you can see that one, upper laser level. From that upper laser level, they just come down. This is the correct picture. Instead of argon, you can think about krypton, both behave similarly. This krypton ion plus fluorine, instead of chlorine, I have chosen fluorine here. I said about argon, chlorine, instead of argon, I can say the krypton, instead of chlorine, I can say the fluorine. You know, fluorine is more reactive. So, they two, both of them get excited. Under the excitation condition, they get combined, or you can say they get married, they form a transient molecule which is called krypton fluoride, which is an exciplex, excited state complex, and then they produce a photon. Once they produce a photon, they dissociate, they run away from each other. When they produce a photon, they produce a photon at 268 nanometer, I think 268 nanometer. These photons are plenty in number. Where are they? In the same kind of channel which I showed you for nitrogen laser, the same kind of channel. Then you have two mirrors which will send back the light and forth. If the optical gain is very high, even in 3 or 2 trances back and forth, these photons are capable of producing stimulated emission and producing intense pulsed laser action, which is called krypton fluoride laser or argon chlorine laser. Now, all these would be in the ultraviolet region. I can show you a variety of excimer lasers, exciplex lasers are there. Argon, krypton fluoride, if you look at it, it produces laser at 248 nanometer. Instead of krypton, if I choose argon and fluorine, I can get 192 nanometer. Not only that, instead of argon and fluorine, I can choose krypton and chlorine, I will have another laser. What I am trying to bring to this one, bring to the attention is, I have a variety of gases, variety of noble gases like helium, neon, argon, argon, krypton, like that, and there are very highly reactive gases like fluorine, chlorine. Bromine is useless, it is a stupid gas. Fluorine and chlorine are very reactive gases. You can make any mix, you can make a sambar again, you can choose any one of the combination, make some small changes in the operational parameter, then you will be able to get a variety of laser. All of them will be in the ultraviolet, starting from 351 nanometer using xenon and fluoride to the shortest wavelength is about argon 2, that is 2 argon. Under the high excitation, they combine together 2 non-reacting argon atoms, forming a transient molecule in the excited state is called excimer. Excited state dimerization is called excimer. They produce ultraviolet light at 125 nanometer. On the other hand, if argon combines with fluorine, it is called exciplex, excited state complex, then you get another laser at 193 nanometer. You can choose variety of noble gases, variety of very reactive gases, combine ultraviolet pulse laser starting from 4 megawatt peak power to 15 megawatt peak power. Remember, this is the peak power, and the pulse width is about usually 15 to 20 nanosecond. That means the average energy will be just about few millijoule. All these excimer lasers or exciplex lasers can work in a very fast speed, very high speed, and then you can have 20 pulses per second or even more. So, average energy will be very high, about 50 millijoule. All these are possible. Among all these excimer or exciplex laser, one of them, I think 193 argon fluor laser is the most important, which is commonly used for corneal sculpting. Perhaps I have told you at the beginning itself, excimer lasers are very useful for photorefractive keratomy. That is, they can change the curvature of the cornea, and the whole operation, actual operation, would take only about 10 or 20 seconds. Only the preparation will take few minutes, but actual surgery will take only few seconds. In fact, actual work will be few nanoseconds again, because all these pulses are coming only with the pulse duration of about 10 to 20 nanosecond, and they are capable of just removing atomic layer alone. So, in this way the damage done to the cornea is practically nil, and this is again most respected ophthalmology laser. Now, forget this ophthalmology for the time being. They are very useful in thin film manufacturing. Why we are talking about thin film manufacturing? They are the starting point for any other chips. So, these ultraviolet lasers are very productive in a variety of chip making industry. Chip is the essential feature in your mobile, in your laptop, in any electronics. Microelectronics live with chips, they live with ultraviolet lasers like excimer or exciplex laser. I have touched upon a number of lasers, solid state lasers like ruby, liquid lasers, gas lasers, etc. there are two more lasers which I should bring to your attention. One is a semiconductor laser, the other one semiconductor laser, other one is a neodymium laser, which I will take it up later in the subsequent lecture. Thank you very much.